They spent 11 days trying to fix a machine that did not want to be fixed. 11 days of the best mechanical engineers the United States Army had to offer, men with degrees from MIT and Georgia Tech, and the kind of confidence that comes from never being wrong before, standing around a 68-ton M1 Abrams tank in the Iraqi desert, scratching their heads like kids who had just been handed a calculus exam in a language they did not speak. 11 days. And the tank just sat there, dead as a monument, cooking in the sun, refusing to breathe. This is a story about what happens when the smartest people in the room cannot solve the problem, and about the one man nobody thought to call who solved it in less than 40 minutes. Not because he was smarter, but because he knew something they had forgotten how to know. It was the spring of 2005, and the American military was deep into the kind of war that did not follow the rules anyone had written down. The invasion of Iraq had happened 2 years earlier, and by now the initial shock and all had given way to something uglier, something slower. The insurgency was picking up speed, and the roads that American convoys traveled every day were becoming more dangerous with each passing week. Improvised explosive devices were hidden under trash bags and dead animals and broken concrete. Snipers waited on rooftops in towns whose names most Americans back home could not pronounce. And the vehicles that were supposed to keep soldiers alive were being pushed harder and farther than they had ever been designed to go. The M1 Abrams was the crown jewel of the American armored fleet. It was the most powerful main battle tank in the world. It weighed nearly 70 tons. It could fire a 120-millimeter smoothbore cannon while moving at full speed and hit a target 2 miles away. Its armor was a classified composite that could absorb direct hits from most anti-tank weapons on the planet. And its engine was a marvel of engineering, a Honeywell AGT 1500 gas turbine that produced 1,500 horsepower and could run on just about any fuel you poured into it. Jet fuel, diesel, kerosene, gasoline. The Abrams did not care. It drank whatever you gave it and turned it into raw, terrifying power. But the engine was also the tank's greatest weakness because it was complicated in ways that most mechanics were never fully trained to understand. The AGT 1500 was not a normal engine. It was essentially a jet engine mounted inside a tank. It had a compressor section, a combustion section, and a power turbine, all spinning at thousands of revolutions per minute, all generating heat that could melt steel if something went wrong. The exhaust from the rear of the tank was hot enough to burn skin from 10 feet away. The air intake system sucked in desert sand and dust with a kind of industrial hunger that clogged filters and ate away at turbine blades over time. And the electronic control systems that managed fuel flow and ignition timing and power output were sensitive in ways that made the engine brilliant when it worked and nearly impossible to diagnose when it did not. This particular Abrams belonged to the 3rd Armored Cavalry Regiment, a unit that had been operating out of a forward operating base near Tal Afar, a city in the northwestern corner of Iraq that sat along one of the main smuggling routes from Syria. The regiment was responsible for an area of operations the size of a small American state, and they were stretched thin. Every vehicle mattered. Every tank that was out of service meant a gap in the line, a patrol that could not go out, a convoy that had less protection. The tank had been on a routine patrol when it died. Not a dramatic death. No explosion. No enemy fire. The crew had been rolling down a supply route on a Tuesday afternoon. The kind of afternoon where the sun turned the sky white and the air tasted like metal when the engine simply stopped. One moment it was running, humming with that high-pitched turbine whine that was the signature sound of the Abrams, and the next moment it was not. The driver tried to restart it. Nothing. He tried again. Nothing. The tank coasted to a stop on the side of the road like a shopping cart that had run out of momentum, and then it just sat there. The crew called it in. A recovery vehicle was sent. The tank was towed back to the forward operating base, and the mechanics went to work. The first team to look at the tank was the unit's own maintenance platoon. These were the organic mechanics, the soldiers who were assigned to the regiment, and who worked on the vehicles every day. They were good at what they did. They could change a track in the dark. They could replace a road wheel with a concussion headache and 3 hours of sleep. They knew the Abrams the way a farmer knows his tractor, through daily contact, through grease under the fingernails, through the accumulated knowledge of what broke and how to fix it. But the engine was different. The engine was the one part of the tank that most unit-level mechanics were not fully qualified to work on. They could do basic maintenance. They could change filters and check fluid levels and swap out certain components. But the deeper diagnostics, the stuff that required understanding the turbine's internal logic that was supposed to be handled by specialists, the mechanics did what they could. They checked the obvious things first. Fuel supply, filters, electrical connections. The fuel system looked fine. The filters were dirty, but not clogged enough to cause a shutdown. The electrical connections were intact. They hooked up the diagnostic equipment, a portable computer system that was supposed to read the engine's electronic control unit and spit out a fault code that would tell them what had gone wrong. The diagnostic system gave them nothing. No fault code. No error message. The electronic control unit reported that everything was functioning within normal parameters. According to the computer, the engine was perfectly healthy. But the engine would not start. The mechanics tried everything they knew. They checked the ignition system. They checked the starter motor. They checked the fuel injectors. They pulled panels and inspected wiring harnesses and looked for anything that was burned or corroded or disconnected. They spent 3 days on their hands and knees inside the engine compartment, a space so tight and so hot that working in it felt like performing surgery inside an oven while wearing oven mitts. On the 4th day, they called for help. The request went up the chain of command. A direct support maintenance team was dispatched from a larger base, a team that had more equipment, more training, and more experience with the AGT 1500 engine. These are the next level up, the mechanics who handled the problems that the unit-level guys could not solve. They arrived with a truck full of specialized tools and a quiet professional arrogance that said they had seen this before and they would have it fixed by dinner. They did not have it fixed by dinner. They did not have it fixed by the next morning, either. The direct support team went through the same checks the unit mechanics had already done because that was procedure and because they did not entirely trust that the first team had done it right. They found the same results. Everything checked out. No fault codes. No obvious damage. No missing parts. No vergüenzas. The engine was, by every measurable standard, in working order. And yet it sat there, silent, dead, like an animal playing possum for reasons no one could understand. They tried more advanced diagnostics. They brought in an oscilloscope to check the electrical signals going to and from the engine's control unit. The signals looked normal. They checked the compressor blades for foreign object damage, which was common in the desert. The blades were worn but serviceable. They checked the combustion liner for cracks. It was intact. They checked the power turbine for bearing failure. The bearings were fine. By the 6th day, the direct support team was stuck. They had exhausted their diagnostic playbook. They had checked everything they were trained to check, and none of it explained why the engine would not start. The tank sat in the maintenance bay like an accusation, a 68-ton reminder that sometimes the tools and the training and the technology were not enough. The team leader made a call. He requested a subject matter expert from the theater-level maintenance unit, the highest echelon of repair capability available in Iraq. This was the big leagues. The people at this level were not just mechanics. They were engineers. They had worked at the Honeywell factory. They had helped design the AGT 1500. They understood the engine not just as a collection of parts, but as a system, a living thing with behaviors and tendencies and failure modes that were not written in any manual. 2 specialists flew in from Baghdad. They were civilian contractors, former military, the kind of men who had spent 20 years inside turbine engines and who carried their knowledge in their hands the way a surgeon does. They walked around the tank slowly, looking at it the way a doctor looks at a patient, reading its posture, its angles, its condition. Then they climbed inside and went to work. For 2 more days, they worked. They pulled the engine's electronic control unit and tested it independently. It worked fine. They tested the fuel control valve. It was within specifications. They tested the ignition exciter, the component that generated the spark to light the fuel in the combustion chamber. It fired perfectly on the bench. Every component, tested individually, worked. But when they put it all back together and pressed the start button, the engine sat there like a stone. The civilian contractors were baffled. These were men who had fixed hundreds of AGT 1500 engines. They had seen every failure mode the engine could produce. They had worked on tanks that had been hit by RPGs and rolled over IEDs and submerged in rivers. And they had never seen this. An engine that was completely functional in every measurable way, but absolutely refused to run. On the 9th day, the frustration was becoming something more than professional. It was becoming personal. The mechanics and engineers had turned the maintenance bay into a war room, with whiteboards covered in diagrams and fault trees and possible causes. They argued about thermodynamics and fuel atomization and turbine harmonics. They called colleagues back in the United States for second opinions. They pulled technical manuals that were so detailed they read like textbooks for a graduate engineering course. And the tank just sat there. The base commander was getting pressure from above. The regiment needed that tank. Operations were being planned. Patrols were going out shorthanded. Every day the tank sat in the maintenance bay was a day that soldiers were driving through hostile territory with one less layer of protection. The commander wanted answers, and all he was getting were shrugs and furrowed brows and requests for more time. On the 10th day, a young sergeant in the maintenance platoon did something that nobody else had thought to do. Not because they were too proud, although some of them were, and not because they did not know about the option, although some of them did not. The sergeant did it because he was 23 years old and had grown up in a small town in Alabama where the first thing you did when something broke and you could not figure out why was you called the old man down the road who had been fixing things since before you were born. The sergeant went to his platoon sergeant and said he wanted to make a phone call. The platoon sergeant asked who he wanted to call. The young sergeant said he wanted to call Major Raymond Collazo. The platoon sergeant looked at him for a long moment. Major Collazo was not in Iraq. Major Collazo was back at Fort Hood, Texas, working in a training command. He was not a turbine engineer. He was not a factory representative. He was not a subject matter expert in the way the Army officially defined the term. What Major Collazo was, and what everybody who had ever worked with him knew, was something different, something that did not fit neatly into a job description or a technical manual. Major Raymond Collazo was the kind of person who understood machines the way some people understand animals. Not through manuals, not through diagnostic equipment, through something older and less definable. He had spent 22 years in the Army working on armored vehicles, starting as a private in a tank battalion and working his way up through every maintenance position the military had. He had never gone to a fancy engineering school. He had learned his trade the old way by standing next to someone who knew what they were doing and watching and listening and getting his hands dirty until the knowledge lived in his fingers and his ears and his gut. Collazo could diagnose an engine by the sound it made. He could tell you what was wrong with a transmission by the way a tank moved across uneven ground. He once identified a cracked cylinder head on a Bradley fighting vehicle by putting his hand on the engine block and feeling a vibration that no instrument had detected. The soldiers who had worked with him told stories about him, the way fishermen tell stories about the sea, with a mixture of respect and disbelief and the slight suspicion that they might be exaggerating even though they were not. The platoon sergeant thought about it. Then he nodded. The young sergeant made the call. It was early morning at Fort Hood when Major Collazo's phone rang. He was in his office, doing paperwork, the kind of administrative work that the Army loves and that men like Collazo endure the way a caged bird endures a small room. He picked up the phone. The sergeant on the other end explained the situation. He described the tank, the engine failure, the 11 days of diagnostics, the experts, the contractors, the whiteboards full of fall trees, and the fact that nobody could figure out what was wrong. Collazo listened. He did not interrupt. He did not ask about the diagnostic codes or the test results or the specifications. Instead, he asked a question that nobody in 11 days had thought to ask. He said, "Tell me what it sounded like when it died." The sergeant paused. Nobody had asked him that. The diagnostics were all about data. Numbers. Codes. Specifications. Nobody had asked what the engine sounded like. The sergeant closed his eyes and thought back to the day the tank had died. He had been in the maintenance bay when the crew brought it in. He had talked to the driver. He tried to remember what the driver had said. The driver said it was running normal, the sergeant said. And then there was a kind of, I don't know. He said it hiccuped, like it coughed once, and then just wound down. Collazo was quiet for a moment. Hiccuped, he repeated. Not a bang, not a grind, a hiccup. And then it wound down, like it was going to sleep. Yes, sir. And your diagnostics show everything normal. Yes, sir. Everything checks out. Every component works on the bench. Collazo was quiet again. The sergeant could hear him breathing. Then, the major said something that the sergeant would remember for the rest of his career. Your engine's fine, Collazo said. Every part of it is fine. That's your problem. You've been looking at the parts. Stop looking at the parts. The sergeant did not understand. He asked what the major meant. Collazo told him. And what he said changed everything. Major Collazo did not raise his voice. He did not speed up. He spoke the way a man speaks when he is reaching into a part of his mind that is deep and quiet and full of years. The sergeant on the other end of the phone held the receiver close to his ear and did not move because something in the major's tone told him that what was coming next was the kind of knowledge you do not get from a textbook. The AGT 1500 is not a collection of parts, Collazo said. Every young mechanic makes that mistake. Every engineer makes it too, even the ones from the factory. They think of the engine as a fuel system, plus an ignition system, plus a compressor, plus a turbine, plus a control unit. They test each piece. Each piece works. They put it back together. It does not work. And they stand around looking at each other like the engine is lying to them. The sergeant waited. The engine is not lying, Collazo said. The engine is telling you exactly what is wrong. You're just listening in the wrong language. Collazo explained. The AGT 1500 gas turbine was a system, not a machine made of parts, but a system the way a human body is a system. Your heart can be healthy. Your lungs can be healthy. Your blood pressure can be perfect. Every organ tested individually can come back with a clean report. But if the timing between your heart and your lungs is off by a fraction of a second, if the rhythm that coordinates them is disrupted, you collapse. Not because anything is broken, because the conversation between the parts has been interrupted. The engine worked the same way. The compressor fed air to the combustion chamber at a specific pressure and a specific volume. The fuel control valve delivered fuel at a rate that was calibrated to match that air supply. The ignition exciter fired at a precise moment when the fuel-air mixture reached the right ratio. The power turbine extracted energy from the expanding gases at a speed that was synchronized with the compressor. And the electronic control unit managed all of this, making thousands of micro adjustments per second, reading sensors and tweaking outputs, and keeping the entire system in a state of dynamic balance. Every one of those individual functions could test perfectly on a bench. But the bench test did not test the timing. The bench test did not test the conversation. The bench test told you that each musician could play their instrument. It did not tell you whether the orchestra could play together. You have a timing problem, Collazo said. Something has disrupted the synchronization between the fuel control valve and the ignition sequence. Not enough to throw a fault code, because the individual components are within spec, but enough to prevent the engine from establishing a stable combustion cycle. The engine tries to start, the fuel and the spark are not meeting at the right moment, and the control unit reads the failed start as an anomaly and shuts everything down to prevent damage. It is doing exactly what it is designed to do. It is protecting itself from a problem that your diagnostic tools are not built to see. The sergeant felt something shift in his chest. 11 days of frustration and confusion. And this man, 7,000 miles away, sitting in an office in Texas, had just described the problem in 3 minutes without ever touching the engine. How do we fix it? The sergeant asked. You do not fix the parts, Collazo said. You fix the timing. Pull the fuel control valve. Do not test it. Do not bench check it. I know it tested fine. That is not the point. Look at the linkage between the fuel control valve and the electronic control unit. There is a small actuator arm, about 4 inches long, that translates the electronic signal from the control unit into a physical movement of the valve. That arm has a calibration point, a tiny set screw that determines the zero position of the valve. In the desert, with the heat expansion and the sand and the vibration, that set screw can drift. Not much, maybe a quarter turn, maybe less, enough to shift the valve's zero position by a few thousandths of an inch. And that few thousandths of an inch changes the fuel delivery timing just enough to put out of phase with the ignition sequence. The sergeant was writing as fast as he could. The set screw drift will not show up on any diagnostic test, Collazo continued, because the valve itself is still functioning within its allowable range. The computer sees a valve that opens and closes correctly. What it does not see is that the valve is opening and closing at the wrong moment relative to the ignition cycle. The error is not in the magnitude of the movement. It is in the timing of the movement. And no bench test in the world will catch a timing error when you're only testing one component at a time. The sergeant read back his notes. Collazo confirmed them. Then the major added one more thing. When you find the set screw, he said, do not just tighten it. Reset it. Use a feeler gauge. The gap should be 6 thousandths of an inch. Not 5. Not 7. 6. That is the tolerance that Honeywell designed into the system. And it is not in any of the field manuals because Honeywell assumed the set screw would never drift. They were wrong. The call ended. The sergeant stood there for a moment, holding the phone, looking at his notes. Then he walked to the maintenance bay. The maintenance bay was a large tent structure with a metal frame, the kind of temporary permanent facility that the American military built all over Iraq and Afghanistan during the wars. It was hot inside. It was always hot inside. The canvas walls trapped the heat like a greenhouse, and the fans that hung from the frame pushed the hot air around without actually cooling anything. The tank sat in the middle of the bay, surrounded by toolboxes and diagnostic equipment and the accumulated debris of 11 days of concentrated effort. Empty water bottles, MRE wrappers, coffee cups with dried rings at the bottom. The civilian contractors were there, sitting on folding chairs, going over their notes for what felt like the 100th time. One of them was on a laptop, reviewing the engine's technical data package. The other was staring at the whiteboard, which by this point looked like the work of a conspiracy theorist. Lines connecting boxes, connecting questions, connecting dead ends. The sergeant walked up to them and told them what Major Collazo had said. The contractors looked at each other. One of them frowned. The other tilted his head slightly, the way a dog does when it hears a sound it does not recognize. It set screw drift on the fuel control valve actuator arm. The first contractor repeated, "That is not in any failure mode analysis I have ever seen." He said it would not be, the sergeant said. He said Honeywell did not account for it. The second contractor leaned back in his chair. He had been working on AGT 1500 engines for 15 years. He had rebuilt them from the ground up. He had written portions of the technical manuals that other mechanics used. And in 15 years, no one had ever mentioned a set screw on the fuel control valve actuator arm as a potential failure point. "Who is this Major?" the contractor asked. The sergeant told him. The contractor had never heard the name. There was a moment of silence in the maintenance bay, the kind of silence that sits between professional pride and the slowly dawning recognition that professional pride might be the thing standing between you and the answer. The contractors looked at each other again. Then the first one stood up and walked toward the tank. "Let's take a look," he said. They pulled the fuel control valve. They had pulled it before, 3 days earlier, and tested it on the bench and found it working perfectly. But this time they were not looking at the valve. They were looking at the linkage. They were looking at the actuator arm. It was a small component. In an engine that weighed over 2,500 pounds and contained thousands of parts, the actuator arm was easy to overlook. It was about 4 inches long, made of hardened steel, and it connected the electronic control unit's output to the physical mechanism of the fuel control valve. When the control unit sent a signal to increase or decrease fuel flow, that signal traveled through a solenoid, which moved the actuator arm, which moved the valve. It was the translator between the engine's electronic brain and its mechanical body. At the base of the actuator arm, where it pivoted on a small pin, there was a set screw. It was tiny, maybe 3 millimeters in diameter. It sat in a recessed pocket that was partially obscured by the mounting bracket, which is why nobody had paid any attention to it during the previous inspections. Why would they? It was a set screw. It was designed to be set once at the factory and never touched again. The contractor got a flashlight and a magnifying lens. He looked at the set screw. He looked at it for a long time. Then, he looked up at the sergeant. "It has moved," he said. The sergeant felt the hair on his arm stand up. The contractor explained what he was seeing. The set screw had a small witness mark on it, a tiny dab of paint that had been applied at the factory to indicate the screw's original position. The paint mark was supposed to be aligned with a corresponding mark on the housing. It was not. It was offset, not by much, maybe a quarter turn, maybe less, but it had moved. The other contractor came over and looked. He saw it too. He let out a breath that was half whistle and half sigh. "How in the world did your major know about this?" he asked. The sergeant shook his head. "I do not know. He just knew. They got a feeler gauge." They loosened the set screw and reset the actuator arm to the 0 position, using the feeler gauge to set the gap to exactly 0.06 of an inch, just as Collazo had specified. It took about 15 minutes. Then they reassembled the linkage, reinstalled the fuel control valve, and buttoned up the engine compartment. The tank had been dead for 11 days. The best mechanics in the theater had spent more than 100 combined man-hours trying to figure out what was wrong. Thousands of dollars in diagnostic equipment had been deployed. Phone calls had been made to engineers on the other side of the world. Whiteboard had been filled with fault trees and theories and guesses. And now it came down to a 3 millimeter set screw and a feeler gauge. The driver climbed into his seat. He went through the startup sequence. The APU powered up. The displays came alive. He pressed the engine start button. The AGT 1500 gas turbine began to spool. The compressor started to spin, slowly at first, then faster, building speed with a rising whine that climbed through the frequencies like a note being tuned. The combustion chamber ignited. The power turbine caught the expanding gases and began to turn. The engine RPM climbed. The exhaust temperature stabilized. The oil pressure came up. The engine was running. The sound of it filled the maintenance bay, that high-pitched turbine scream that shook the tools on the workbenches and vibrated in the chest cavities of every person standing within 50 feet. It was the loudest, most beautiful sound any of them had heard in 11 days. Nobody cheered. Nobody clapped. They just stood there, looking at the tank, listening to the engine, feeling the vibration in the soles of their boots. The first contractor pulled off his gloves and dropped them on the workbench. He looked at the sergeant. "Call your major," he said. "Tell him thank you." The sergeant did call Collazo. He called him that same day, as soon as the tank had been test-driven around the base and declared fully operational. Collazo answered on the second ring, and when the sergeant told him the engine was running, the major did not sound surprised. He did not say, "I told you so." He did not gloat. He just said, "Good. Get that tank back out there. Those soldiers need it." But the story did not end with the engine starting. That was the fix. The fix was the easy part, in a way. 3 millimeters and a feeler gauge. The harder part, the part that nobody talked about openly, but everybody thought about privately, was the question of how. How did a major sitting in an office in Texas, who had never touched this specific engine, who had no diagnostic data, who had nothing but a second-hand description of a sound the engine made when it died, figure out in 3 minutes what a dozen specialists could not figure out in 11 days? The answer to that question was not simple, and it was not comfortable, especially for the people whose job it was to be experts. Major Raymond Collazo had grown up in a small town in New Mexico. His father had been a mechanic at a copper mine, the kind of man who could keep 40-year-old equipment running with baling wire and stubbornness and an encyclopedic knowledge of how things were supposed to feel when they were working right. Collazo had grown up in his father's shop, surrounded by engines and pumps and compressors, and he had learned the first and most important lesson of mechanical work before he was old enough to drive. His father had taught him that a machine talks to you, not in words, in sounds and vibrations and smells and temperatures. A machine that is healthy sounds different from a machine that is sick. A bearing that is about to fail feels different from a bearing that is happy. An engine that is running rich smells different from an engine that is running lean. And if you listen, really listen with your hands and your ears and your nose and your gut, the machine will tell you what is wrong before any computer can. Collazo had carried that lesson into the Army. He enlisted at 18 and went straight into the maintenance track, starting as a wheeled vehicle mechanic before transferring to tracked vehicles. He spent his first 10 years with his hands inside engines, learning every system the Army had by the method his father had taught him, by touching and listening and paying attention. He was not the fastest mechanic. He was not the most technically sophisticated, but he was the one people called when nothing else worked. Because Collazo did not diagnose engines the way the manuals said to diagnose them. He did not start with the diagnostic computer and work through the fault tree. He started with the story. He asked what happened. Not what the data said happened, but what the people who were there saw and heard and felt when it happened. He wanted the human account, the subjective experience, the details that a computer would never record. And from that story, he would build a picture in his mind, not of individual components, but of the entire system in motion. He would imagine the engine running. He would imagine the fuel flowing and the air compressing and the turbine spinning. And then he would imagine the moment it stopped, and he would ask himself what could cause that specific kind of stop. Not a bang, not a grind, but a hiccup and a wind down. What system behavior produces that particular signature? It was a way of thinking that the modern military maintenance system did not teach. The system taught procedures. It taught fault codes. It taught bench testing and component replacement and technical manuals. All of those things were valuable. All of those things worked most of the time, but they worked by breaking the problem into pieces and testing each piece individually. And sometimes, like with this tank, the problem was not in any individual piece. The problem was in the spaces between the pieces, in the timing and the rhythm and the coordination that made the pieces work together. And no procedure could test for that. Collazo's knowledge was the kind of knowledge that was dying. Not because it was wrong, because it was slow, because it could not be standardized, because it could not be loaded into a computer or written into a manual or taught in a classroom. It lived in the hands and the ears of people who had spent decades paying attention to machines. And when those people retired or moved on, the knowledge went with them. It was not passed down through documents. It was passed down through proximity, through apprenticeship, through standing next to someone who knew and watching them work until you began to see what they saw. The modern military did not have much room for that kind of knowledge. The modern military wanted systems and procedures and databases. It wanted to be able to take a new mechanic, put them through a training course, hand them a diagnostic computer, and have them producing results within weeks. And for most problems, that approach worked. The diagnostic computers were good. The training courses were thorough. The technical manuals were detailed. But they could not teach a person to hear the difference between an engine that was dying because something was broken and an engine that was dying because its parts had forgotten how to talk to each other. That was what Collazo had heard in the sergeant's description. A hiccup and a wind down, not a bang, which would mean catastrophic failure. Not a grinding halt, which would mean a seize component. Not a cough and a sputter, which would mean fuel starvation. A hiccup, one single interruption in the combustion cycle, followed by a smooth, gentle wind down as the turbine coasted to a stop under its own inertia. That was the sound of an engine that had tried to start a combustion cycle, failed because the timing was off, and then been shut down by its own protective systems. The engine was not broken. The engine was confused. And once Collazo knew the engine was confused rather than broken, the list of possible causes became very short. The electronic control unit was the brain. If the brain was damaged, the diagnostics would show it. The sensors were the eyes and ears. If the sensors were lying, the data would be inconsistent. The fuel control valve was the mouth, and the actuator arm was the muscle that moved the mouth. If the mouth was moving at the wrong time, not by a lot, just by a hair, enough to throw the timing off without triggering an alarm, then every component would test fine individually, but the system would not function as a whole. The set screw on the actuator arm was the only thing in the entire fuel delivery chain that could drift without being detected by the diagnostic system. Every other adjustment point had a sensor watching it. The set screw did not. It was a mechanical component in a system that had been designed to be monitored electronically, and the designers had assumed it would never move. But Collazo knew about desert operations. He knew about thermal cycling, the constant expansion and contraction of metal parts as the temperature swung from 130 degrees during the day to 60 degrees at night. He knew about vibration, the relentless shaking that a 68-ton vehicle produced as it drove over unpaved roads and rough terrain. And he knew that set screws over time under those conditions could drift. He knew because he had seen it before. Not on this engine, not on this tank, but on other machines in other places over the course of 22 years. He had seen small, overlooked mechanical connections shift and drift and cause problems that drove intelligent people crazy because they were looking at the wrong scale. They were looking at the big components when the problem was in a 3mm screw. That was the difference between expertise and wisdom. Expertise knows what the manual says. Wisdom knows what the manual left out. The word spread through the maintenance community the way these things do in the military, through informal channels, through conversations over coffee and cigarettes, through emails and phone calls between mechanics who knew each other from previous assignments. Within a week, every maintenance unit in the theater had heard the story of the tank that died and the major who fixed it with a phone call. Within a month, a technical bulletin was drafted recommending that the fuel control valve actuator arm set screw be checked as part of the routine maintenance schedule for the AGT 1500 engine. Within a year, the check was incorporated into the official maintenance manual. But the story that the mechanics told each other was not about the technical bulletin. The technical bulletin was just a line item on a checklist. The story they told was about the major. About the man who listened to a sound described over a phone from 7,000 miles away and saw the problem like it was sitting in front of him. About the kind of knowledge that you cannot download or install or upgrade. The kind that takes a lifetime to build and that lives nowhere except inside the person who built it. The story had an uncomfortable edge to it, too, because wrapped inside the admiration and the awe was a question that nobody wanted to answer. What happens when the last major Collazo retires? What happens when the last person who can hear an engine's heartbeat hangs up their tools and goes home? What happens when the only knowledge left is the kind that fits in a computer? Nobody answered that question in 2005. Nobody had to, because Collazo was still there. And as long as he was there, there was someone to call when the experts were baffled and the computers were silent, and if a 68-ton machine sat dead in the desert for no reason that anyone could find. But Collazo was not going to be there forever, and the machines were not going to stop breaking in ways that the computers could not see. That was the part of the story that kept people up at night. The tank went back to war the next day. The crew drove it out the gate of the forward operating base at dawn, rolling onto the same supply route where it had died 12 days earlier, and for the first 20 minutes nobody in the crew said anything. They just listened. The engine's turbine whine filled the hull the way it always did, steady and clean and uninterrupted, and the driver kept his hands on the controls and his eyes on the road, and his ears tuned to a frequency he had never paid attention to before. He was listening for a hiccup. He was listening for the sound of a machine forgetting how to breathe. The hiccup did not come. The engine ran the way it was supposed to run, the way 1,500 horsepower sounds when everything is in rhythm, when the fuel meets the spark at the right moment, and the turbine catches the fire and turns it into motion. The tank moved down the road like something alive, 68 tons of steel and ceramic armor gliding over the broken pavement with a smoothness that seemed impossible for something so heavy. The crew relaxed. The gunner made a joke about the engine taking an 11-day vacation. The loader laughed. The driver did not laugh. He was still listening. Back at the forward operating base, the maintenance bay was quiet for the first time in nearly 2 weeks. The toolboxes were closed. The diagnostic equipment was packed up. The whiteboard had been erased. The civilian contractors had packed their bags and were waiting for a helicopter back to Baghdad, and the unit mechanics were catching up on the backlog of other vehicles that had been neglected while everyone focused on the dead Abrams. But the story was not done traveling. Stories in the military move through a network that is older than the internet and more reliable. They move through the NCO Corps, the non-commissioned officers who are the backbone of every army in the world, the sergeants and staff sergeants and sergeants first class who do the actual work of keeping a military functioning. These men and women talk to each other constantly across units and across bases and across time zones, sharing information that the official channels are too slow or too formal to carry. Who has spare parts? Which commanders are good and which are dangerous? Which mechanics can actually fix things and which ones just follow the checklist and pray? The story of Major Collazo and the dead tank entered this network and spread like a rumor with a punchline. Within days, mechanics at other forward operating bases were telling it. Within weeks, it had reached the big logistics bases in Kuwait and Qatar. Within months, it had crossed over into the Air Force and Navy maintenance communities, where it was retold with different details, but the same essential shape, the same moral. The moral was always the same, no matter who told it. The computers could not see the problem. The procedures could not find it. The experts could not solve it. And then someone who did not rely on computers or procedures, someone who relied on something older and harder to name, solved it in the time it takes to drink a cup of coffee. The story made people uncomfortable. It was supposed to, because the story was not really about a tank engine. The story was about a question that the entire modern military and the entire modern world was struggling to answer. A question about knowledge, about what kind of knowledge matters, about what gets lost when you replace human intuition with digital precision. The United States military had spent the previous 2 decades investing heavily in technology. Computerized diagnostic systems, digital maintenance tracking, automated supply chains, predictive analytics that were supposed to tell you when a part was going to fail before it failed. All of this technology was good. All of it had saved time and money and, in some cases, lives. But all of it had also come with a cost that was harder to measure, a cost that showed up not in budget reports, but in moments like this one, when a 68-ton tank sat dead in the desert and the technology had nothing to say about it. The cost was the slow erosion of the kind of knowledge that Major Collazo carried. The experiential knowledge, the sensory knowledge, the knowledge that lived in the hands and ears of people who had spent decades in close physical contact with machines. This knowledge was not anti-technology. It was not opposed to computers or diagnostics or modern methods. It was the foundation that those modern methods were supposed to be built on top of. But somewhere along the way, the foundation had been mistaken for the building. The modern methods had become the thing, and the old knowledge had become the optional extra, the quaint tradition, the nice-to-have that nobody had time or budget to maintain. Major Collazo saw this happening. He had been watching it happen for years. He watched as the Army's maintenance training programs shifted their emphasis from hands-on apprenticeship to classroom instruction and computer-based testing. He watched as young mechanics arrive at their units knowing how to read a diagnostic screen, but not knowing how to listen to an engine. He watched as the promotion system rewarded soldiers who were good at administrative tasks and digital systems over soldiers who were good at fixing things with their hands. And he watched as the institutional memory, the accumulated wisdom of generations of mechanics who had learned by doing, began to thin and fade like a photograph left in the sun. He tried to do something about it. In his position at the training command at Fort Hood, he pushed for changes to the maintenance curriculum. He argued that every young mechanic should spend a minimum of 6 months in an apprenticeship with an experienced technician before being allowed to use diagnostic equipment independently. He argued that the training should include what he called sensory diagnostics, the ability to diagnose a machine by sound, vibration, smell, and touch. He wrote memos. He gave presentations. He cornered colonels at social functions and talked their ears off about turbine harmonics and the dying art of listening to machines. Most of them listened politely. Some of them agreed with him. Almost none of them had the authority or the budget to implement what he was proposing. The military training system was a massive bureaucracy with its own momentum, and changing its direction was like trying to turn an aircraft carrier with a canoe paddle. There were too many competing priorities, too many budget constraints, too many stakeholders who believed that the future of maintenance was digital and that the past, with its greasy hands and its gut feelings, was a chapter that was closing. Collazo was not bitter about this. That was not his way. He was a practical man who understood that large organizations move slowly and that change, when it comes from the ground up, not the top down. So he did what he could, where he could, with what he had. He mentored young mechanics individually. He took them into the motor pool and stood with them next to running engines and taught them to hear the things that no diagnostic screen would show them. He taught them to put their hands on an engine block and feel the rhythm of the pistons. He taught them to smell the exhaust and know whether the fuel mixture was right. He taught them to watch the way a vehicle moved over rough ground and read its suspension like a sentence in a book. Some of them got it. Some of them did not. The ones who got it were the ones who came to it with the right kind of patience, the willingness to stand still and pay attention for a long time before expecting to understand anything. The ones that did not get it were the ones who wanted the answer immediately, who wanted a checklist, who wanted the machine to tell them what was wrong in a language they could read on a screen. Collazo did not judge the second group. He understood them. They were products of a system that had trained them to expect immediate, measurable, digital answers. They had grown up in a world of search engines and smartphone apps and instant information. The idea that some knowledge could only be acquired through years of silent, repetitive, physical experience, that some things could not be Googled, was foreign to them. Not because they were unintelligent, but because nobody had ever told them. The story of the dead tank in Iraq became one of the tools Collazo used in his teaching. He told it not to brag, because bragging was not in his nature, but to illustrate a point. The point was not that computers are bad. The point was not that old methods are better than new methods. The point was that the most dangerous kind of failure is the kind your tools are not designed to detect. And the only defense against that kind of failure is the kind of knowledge that cannot be automated. He told the story in a classroom at Fort Hood to a group of young mechanics who had just graduated from their technical training and were about to be assigned to their first units. He told it simply, without drama, in the flat and steady voice of a man who had no need to impress anyone. When he got to the part about the set screw, he paused and looked at the class. "A 3mm set screw," he said. "That is what stopped a 68-ton war machine. Not a bomb, not a bullet, not a catastrophic failure that set off every alarm in the system. A 3mm set screw that drifted a quarter turn because the desert is hot during the day and cold at night, and metal expands and contracts, and sometimes the things we assume will never move decide to move." He let that sit. "Your diagnostic computers will not catch that," he said. "Your fault trees will not lead you to it. Your technical manuals will not mention it, because the engineers who designed the engine did not believe it could happen. And if you rely on those things, and only those things, you will stand in a maintenance bay in 130-degree heat, surrounded by the most advanced diagnostic technology in the world, and you will not be able to fix a machine that is broken because of a problem the size of a grain of sand." He paused again. "But if you learn to listen," he said, "the machine will tell you." The young mechanics looked at him. Some of them were taking notes. Some of them were not. Some of them would remember this moment years later, in maintenance bays of their own, when they faced problems that their computers could not solve. And some of them would forget it by lunch. That was the nature of the thing. You could not force this kind of knowledge into people. You could only create the conditions for it, and then wait. Like planting seeds in ground you could not control. Some would grow, some would not. You did your part, and let the rest go. Collazo retired from the Army in 2009 after 26 years of service. He left without fanfare, the way most career soldiers leave, with a ceremony at the unit headquarters, a folded flag, a few speeches that said the right things, and then a drive through the gate for the last time. The gate guard saluted. Collazo returned the salute. And then he was a civilian. He went home to New Mexico. He bought a small piece of land outside of Las Cruces, in the high desert where the light was sharp and the air was dry and the nights were cold enough to make you grateful for a warm engine. He built a shop behind his house, a proper shop with a lift and a compressor and tool chest that he had accumulated over 26 years. And he kept working on machines. Not military machines, civilian machines, trucks and tractors and generators and the ancient diesel engine that powered the irrigation pump on his neighbor's ranch. He was happy, or something close to it. He had his hands in engines again, and the engines talked to him the way they always had, in their language of sound and heat and vibration, and he listened the way he always had, with the patience of a man who had spent a lifetime learning that the most important things in the world cannot be rushed. But the military did not entirely let him go. Every few months, he would get a phone call, sometimes from a former student, sometimes from a maintenance officer he had worked with years ago, sometimes from a young mechanic who had heard the story and tracked down his number through the network of NCOs and veterans that stretched across the country like an invisible web. The calls were always the same. Something was broken. The computers could not find the problem. The procedures had been followed. The experts had been consulted. And now someone was standing in a maintenance base somewhere, sweating and frustrated and out of ideas, and they were calling the old man in New Mexico because they had heard that he could hear things that other people could not. Collazo always took the calls. He always listened, and more often than not, he could point them in the right direction. Not always. He was not magic. He was just experienced, and experience, true experience, the kind that is built over decades and stored in the body, and the mind as a single integrated system is the closest thing to magic that the physical world produces. He solved problems with Bradley fighting vehicles and Stryker armor personnel carriers and 5-ton trucks and generators and water purification systems. He solved them from his kitchen table and from his shop and once from the cab of his pickup truck while he was waiting for his wife at the grocery store. He solved them by asking questions that nobody else thought to ask. Not what does the computer say, but what did it sound like? Not what did the test results show, but what did the mechanic feel when they put their hand on the engine block? Not what does the manual say, but what does your gut tell you? His reputation grew quietly in the way that reputations grow among people who do real work. He became one of those names that got passed around in maintenance circles, the kind of name that came with a story and a phone number and the advice to call him before you wasted another 3 days following the fault tree to nowhere. The Army never officially acknowledged what Collazo represented. There was no program named after him. There was no doctrine that codified his approach. There was no school that taught his methods. His knowledge remained what it had always been, personal, experiential, untransferable in any systematic way. It went with him when he left, and it would go with him when he died, and the only traces it would leave behind were the memories of the people he had taught, and the stories they told each other about the old major who could hear a set screw drift from 7,000 miles away. There was something profoundly sad about that, and something profoundly human, because the truth that the story of the dead tank illuminated was not a truth about engines or set screws or diagnostic computers. It was a truth about people, about the kind of knowledge that can only be built by a human being who is willing to be present physically and mentally present with the material world for a very long time. A kind of knowledge that cannot be shortcut or automated or uploaded. A kind of knowledge that the modern world, with its worship of speed and efficiency and scalability, was systematically devaluing even as it became more necessary. The tank in Iraq was one example. There were thousands of others in every field, in every industry, in every corner of human life. Doctors who could diagnose a disease by the way a patient walked into the room. Pilots who could feel an aircraft's intentions through the seat of their pants. Farmers who knew it was going to rain by the way the wind smelled. Bakers who knew the bread was ready by the sound it made when they tapped the crust. None of this knowledge could be measured. None of it could be standardized. None of it could be taught in a PowerPoint presentation or verified by a multiple choice test. And all of it was disappearing. Not because it was being rejected, because it was being neglected, because the systems that were supposed to support it, the apprenticeships and the mentorships and the long, slow years of standing next to someone who knew, were being replaced by systems that were faster and cheaper and more efficient in every way except the one that mattered most. The one that mattered most was the ability to solve problems that the systems themselves could not see. That was what Major Collazo knew. That was what the dead tank taught everyone who heard the story. And that was what kept the young sergeant from Alabama up at night, years later, when he had become a staff sergeant and then a sergeant first class and was training his own mechanics and trying in his own way to pass on the thing that could not be passed on through any official channel. He taught them to listen. He stood with them next to running engines and told them to close their eyes and just listen. Not for anything specific. Just listen. Let the sound enter them. Let the rhythm register. Let the machine talk. Some of them thought he was strange. Some of them thought he was wasting their time. And some of them, the ones with the right kind of patience, the ones who were willing to stand still for a long time before expecting to understand anything, heard something. Not a fault code, not a diagnosis, something quieter and more fundamental. They heard a machine breathing. And that was the beginning. The tank that died in Iraq in 2005 served for another 6 years after Major Collazo's phone call. It rolled through Tal Afar and Mosul and a dozen other cities and towns whose names became synonymous with a war that went on far longer than anyone had planned. It took hits from small arms fire and shrapnel from roadside bombs. It carried soldiers through ambushes and firefights and the long, grinding monotony of occupation duty. Its engine ran hot and loud and faithful, 1,500 horsepower of controlled fury, and the crew that drove it never forgot what had brought it back to life. A 3mm set screw, a phone call, and a man who knew how to listen. Years later, at a veterans reunion in Texas, the driver of that tank met the young sergeant who had made the call. They were both older now, thicker around the middle, carrying the quiet weight that men carry when they have been to war and come back and are trying to figure out what the rest of their lives are supposed to look like. They shook hands. They talked about the tank. They talked about the 11 days. They talked about Major Collazo. The driver asked if a sergeant had stayed in touch with the major. The sergeant said he had. He said he still called Collazo every few months, not always about engines, sometimes just to talk, the way you call someone who taught you something important and who you do not want to lose track of. The driver nodded. He looked down at his beer. He was quiet for a moment. You know what I think about sometimes? The driver said. I think about the fact that our entire mission, the patrol, the convoy protection, the things we did in that tank for the next 6 years, all of it came down to a phone call that almost did not happen. If you had not thought to call him, if your platoon sergeant had said no, if the major had been busy or had not answered his phone, that tank sits in the maintenance bay until someone decides to deadline it and ship it back to the States for depot-level repair. And we get assigned a different vehicle. And everything is different. The sergeant nodded. Everything is always one phone call away from being different, he said. That is what I learned. Not just about engines. About everything. The answer is always out there. It is always sitting in someone's head, in someone's hands. You just have to know who to call. The driver smiled. It was a small smile, the kind of smile that is not really about happiness, but about recognition, about seeing a truth that is simple and enormous at the same time. And you have to be willing to call, the driver said. You have to put the pride down and pick up the phone. They clinked their bottles. Somewhere in New Mexico, in a shop behind a small house in the high desert, an old man was listening to an engine. Not because it was broken, because it was beautiful, Because the sound of a machine running right, every part in conversation with every other part, every rhythm locked and steady and true, was one of the finest sounds in the world. Because listening was not a skill he had learned. It was a way of being in the world. It was the thing he had been put here to do. The engine ran. The old man listened. And the desert was quiet around them both.